Our prompt was tracking the threat of antibiotic resistance, and our project was on high-risk antibiotic resistance region alerts for MRSA.
In the United States, antibiotic resistance is on the rise, and while 91% of physicians understand that this is an issue, only about 36 are aware of the role that their practice could play in the mitigation of antibiotic resistance.
So we're using three ratios to track the antibiotic resistance threat. One is an infection ratio, SAR is an antimicrobial administration ratio, which is similar to the amount of drugs dispensed, and the percent non-susceptibility is the amount of antibiotic-resistant bacteria that are present. When all of these ratios go up, the threat for antibiotic resistance is high.
Due to the lack of chronological alignment between our different data sets, the scope of our project was limited. We focused on the adult population of hospital-acquired infections, and we had to aggregate data to only be on a state-by-state basis. We also only looked at MRSA, and our span of time was limited to only a few years. We also only looked at the scope of antibiotic resistance in acute care settings.
Now, what you're seeing here is an interactive map visualizing key indicators of antibiotic resistance and infection rates across the US. So this includes metrics like the SIR values and predicted non-susceptibility rates. So by toggling through the dropdown, we can explore how states compare in terms of antibiotic stewardship and infection risk. This dashboard not only highlights trends, but also helps prioritize regions needing targeted intervention to further investigation. Here are some attention to details where we have insufficient data displayed as insufficient data for clarity and exact ratios as well.
One prediction model that is commonly used is the ARIMA model, and we put this into our visualizer. This ARIMA requires a stationary time value, and you can check it with these tests in Python as well.
So the limitations of the ARIMA model show when we show the Virginia SIR forecasted versus the actual value in 2021. ARIMA relies on precedent, so it takes into account the previous values and trends, and we know that 2020 was a crazy year that was not precedented, so ARIMA failed to predict correctly for 2021. So we'll have to look at other machine learning models.
Another option that doesn't require a stationary time variable necessarily is machine learning scikit package for Python. It was still limited due to our lack of data corresponding to each year, like to do multivariate work, but we ran it and we can get data to put into our visualizer.
So the end goal of this is to get out custom directives based on this data to specific providers in specific units of specific hospitals within specific states. So we think a lot of the issue is knowing that there's a threat of antibiotic resistance, but the messaging is very general. So if we had customized directives like the one shown here to an individual unit based on the data, that would give us a better chance against the threat.
The actual robustness of our tool is limited by the data that was available to us, but in the future, researchers with more robust data organization tools could use our foundation to create more accurate projections of antibiotic-resistant healthcare-associated infections and visualize those differences very clearly. We have an urgent need for publicly available public health crisis mitigation tools. Currently, organizations like the AMA have taken up the slack caused by the NIH being defunded, but this tool could serve as a supplement to those efforts. The defunding of public health research in the United States has motivated us to commit our project to GitHub as an open source tool for future research and public health initiatives. Currently, data from 2011 to 2015 is more properly documented and organized than that from recent years. So in the future, we hope that researchers will be able to clean up current data and make more accurate projections for the future.